Welcome back. This video will break down three powerful algorithmic strategies: greedy, divide and conquer, and dynamic programming using real world problems and Python logic. Let's start with greedy algorithms. These build solutions step by step, always choosing the locally best option. But remember, greedy doesn't always mean correct. You need a formal proof to guarantee global optimality. Popular greedy algorithms include these. In interval scheduling, we select non-overlapping time slots, like booking a video classroom. The optimal greedy choice, earliest finish time. For minimizing lateness, like scheduling 3D printer jobs, sorting by increasing deadlines gives the best result. Huffman coding combines the least frequent symbols recursively, using a heap instead of linear scans, reducing the complexity from k square k log k. Next up, divide and conquer. We split the problem into smaller parts, solve each recursively, and combine the results efficiently. Counting inversions helps compare rankings. The closest pair of points uses geometry and recursion. And this algorithm speeds up integer multiplication to the complexity of n raised to 1.59. Quick select finds the kth largest element efficiently, median of medians. It achieves complexity of n as a worst case time. Recursion trees help us analyze these algorithms, visualizing how work splits and accumulates. Now, dynamic programming. It solves overlapping with optimal substructure. We use memoization or tabulation to avoid redundant work. Grid paths count ways to reach a point. LCs and LCW find common sequences in strings. Then edit distance measures how many changes are needed to transform one string to another. Matrix multiplication is associative, but the order matters. Dynamic programming helps us find the optimal parenthesization to minimize operations with a complexity of n cube. To recap, greedy versus divide and conquer versus dynamic programming. So, greedy is fast, but it needs proof. Then, divide and conquer breaks problems into clean parts, while dynamic programming handles overlaps and builds solutions bottom up. Thanks for watching. If you found this helpful, like, subscribe, and share it with your fellow coders. More algorithmic dives coming soon.